Right, we are on to our second part of glacial landforms. If you remember last time that glaciers are huge agents of erosion. They take material that has broken off from the mountainsides due to freeze-thaw weathering, that lands on top of, gets inside of, and gets ground underneath the glacier, and erodes mountains, plucks bits of rock away, scratches at the rock. But all that material that's been eroded from the mountainsides then gets carried along with the glacier itself. The glacier acts like a conveyor belt, picking up rock and slowly but surely transporting it further and further downhill. Eventually, when the glacier melts at the end of the glacier, all of that material transported has to be deposited. And actually, as much as glaciers are huge agents of erosion, they are also responsible for massive features of deposition, where new mounds of material is built up by the glaciers themselves. And we're going to be learning about two major types of material that's deposited. Firstly, I've done it again, damn it. Firstly, moraine, which is glacially deposited material. And we're going to be looking at a special type of moraine called drumlins. But we're going to look at these four types of moraine. So, let's just recap that a glacier is by no means just made of ice. In fact, if you remember, have a look at this photo. You can see that this glacier is, well, it almost looks 50% rock and 50% ice. And especially near the end of a glacier, that's certainly what it can end up being. As the ice melts and forms water, the material that's left behind is increasingly piles of rock. Imagine if this scene was suddenly raised in temperature by 50 degrees. All the ice would melt, and all that would happen is that this rock would just fall as a big pile. And when glaciers do that, the piles that are left behind are known as moraine. So this is the end of a glacier. The glacier is actually extending all the way up here. And you can see the ice, lots and lots of rock debris in the ice, on the ice. And all this material in front of the ice here has been deposited by this particular glacier as it's been melting. Now, if the glacier retreated back, if the temperatures rose, then all this material would get deposited. But actually, big piles of material are deposited when glaciers remain, the end of the glacier remain at the same point for many tens, hundreds, even thousands of years. If climates stay relatively steady, then what happens is that the ice is constantly moving downhill, but the end of the glacier appears stationary. So a bit like standing on a treadmill that you might have in the gym. If you poured a big pile of sand on one end of the treadmill, it would be transported to the end and it would just get piled up at the bottom of the treadmill. And this is what's happening here. Material is constantly being transported and rock debris is piling up in bigger and bigger piles at the end of the glacier. As it melts, material gets deposited on the ground. And you can imagine this is like the treadmill, constantly bringing new material and building a pile higher and higher on the valley. Now this is quite a dramatic image of a glacier in Greenland, coming up from the highest points of the mountainous regions, coming downhill, and you can see it spreads out as it gets flatter and flatter. But in front of the glacier you can see this ridge of material. This is what we call a terminal moraine. Moraine is the name given to any glacially deposited material. This is called terminal moraine because it's found at the end of a glacier. So this is our treadmill, constantly transporting material further down. As it reaches lower and lower altitudes, it's melting and more material is being deposited in this line of moraine. Now if temperatures suddenly rose and the end point of this glacier retreated to this sort of level here, what would be left is just this pile of moraine, and you might actually get a lake forming in front of it. In fact, the next slide shows an example of this. So this slide shows that this glacier here used to probably fill this whole lake, a bit like the original photo, the last photo. And this is the ridge of material left behind. And that as this glacier is retreating further and further back, all that's left is this ridge of material. In this instance, with a lake in front of it, because it's kind of being dammed in. So this is an example of terminal moraine. Now, a photo here of a glacier in the Swiss Alps, and again you can see quite how dirty these glaciers are. Up in the zone of accumulation up here, it's covered in nice fresh snow, but as that glacier moves down into warmer and warmer altitudes, the snow melts away and all that's left is the glacial ice. Now, as the glacier's moving further downhill, it's transporting loads of material. But most of the rock debris in a glacier is actually found at the sides of the glacier. Because as freeze-thaw weathering occurs in these high mountainous regions, rock is constantly falling down the hills and it's getting trapped on the sides of the glacier, forming huge piles of material that are being then swept and carried downhill by the glacier moving. In fact, you can see these ridges of material at the sides. Now, when the glacier melts, if the end of the glacier, which is now down here, if it ends up being here or up here or here or here, what's left behind on the sides of the valley are these huge piles of material. Now, this image shows a glacier which probably at one point used to fill this whole screen, but now the snout of the glacier is moving uphill. And these big piles of material at the sides of the valley, you can see them, crisp material, but it's all just random bits of rock transported by the glacier. These are also known as moraine. But this time, they're not found at the end of the glacier, they're found all the way down the side. And they're known as lateral moraine. Now, the third major type of moraine that we're going to look at is indicated by these red arrows on this image. When two glaciers join together, we'll have a look at this one first. We've got one glacier up here moving downhill. It's joining with another glacier coming from the left, moving over here. Now, both of these glaciers have lots of material trapped down their sides. So we've got lateral debris found here and another load of lateral debris found here. When these two glaciers join together, those two bits of lateral debris join together to form a ridge of what we call medial moraine. And again, you can see here we've got a glacier coming down here and a glacier coming down here. We've got a ridge of material here. And actually this glacier is probably several hundred meters thick, but you can just about make out the very top of the big band of lots and lots of rock trapped, squeezed in between the two glaciers as they join together. Now, if this glacier melted, what we would find in this instance is we wouldn't just find a pile of lateral moraine at the side, we would also find a ridge of moraine running down the length of the valley. In fact, another one there and another one here. We'd have 1, 2, 3, 4 ridges of material of medial moraine. This is a glacier in America, and in fact we can see one of these ridges of medial moraine. There used to be, during the Ice Age, a much bigger glacier here. A glacier going down this side and another glacier going down here, filling Clark Canyon. And in between the two is this ridge of material. And in the last slide, all we saw was this very top part sticking out through the ice. But all this ice has melted away, leaving behind this huge ridge of material. This diagram shows that ridge of material as it would have looked. So imagine that image of the glaciers covering the side and just that band of dark material. As that glacier is melted away, it's left a glacial valley here and a glacial valley here with this moraine, this medial moraine, running down the middle. So, loads of information. But what I would like you to do is to put a title in your books, Types of Glacial Moraine. Copy this diagram, or a version of it, and I would like you to add extra labels to explain each of the 3 types of moraine we've talked about. So talk about terminal moraine running across the valley. Talk about lateral moraine formed at the sides and why we get lateral moraine at the sides, because of all the freeze-thaw weathering causing material to fall down and get trapped between the valley and the glacier. And then medial moraine down the middle. The 4th type of moraine we haven't talked about is something called ground moraine. And ground moraine is really when the glacier melts further and further back, it's all the material just left scattered around the valley bottom, and you'll usually find lots and lots of material, this time not in neat piles like these, but just scattered around, and that's known as ground moraine. So make notes on that as well. Now, the final type of landform formed by deposition that we're going to look at is this found in the image here. This image is actually taken in Ribblesdale in the Yorkshire Dales. Now what we can see here is Well, on the first instance, it just looks like a hilly landscape. But these hills are all formed from glacial deposition. As you can see, these hills all seem to be pointing in the same direction. You can see they're all aligned kind of in this sort of line here. Now, when we get hills all facing the same direction like this in a glacial area, they're known as drumlins. And drumlins are formed by a huge ice glacier moving from in this sort of direction. In fact, in this instance, it's moving the other direction. It's actually moving from bottom left to top right, and I'll tell you why we know this in a second. But ice moving in this direction, and all the material trapped underneath the glacier is being reshaped by the ice moving over the top of it. So all of this material is formed from ground moraine. But as the glacier moves over the top of it, it streamlines the material. It's pushing the material in this way, creating a steep side here. And then as the glacier moves over, it's streamlining it, a bit like sandbars in a river. But in this instance, it's the power of ice doing this rather than water. This is again an image of one of them a bit closer up, and we can see we've got a distinctive shape to these drumlins. We've got a steep up valley side and a gentle down valley side, and as the glacier is moving from left to right, it's pushing the material up and then streamlining it down. So what I would like you to do is to draw this diagram to show the main features of the drumlin. And you can see here we've got a steep, what we call stoss end, S-T-O-S-S, and then a gentle lee slope. And they look like eggs with a kind of more rounded end and a more streamlined end down here. Explain how a drumlin is formed. It's formed from ground moraine and a glacier moving over it and streamlining and reshaping the material. Then have a think what is meant by basket of eggs scenery. Go back to that photo of all the drumlins together. The first people who described drumlins saw landscapes like this, and they look like a whole series of eggs laid on their side, all facing the same direction. So drumlins are usually found not as individual features, but as a swarm of drumlins, creating what we call basket of eggs scenery.